you're going to be solving radical and power equations by Salam and Yolda.
Okay, and we also were supposed to have 2 other people in our group, but they decided not to show up and do any work. So if you want to know their names, please contact Salam Mehta.
So this is the problem we're going to be solving for the first example. So what you have to do first for any problem is find the domain restriction. So the domain restriction for this equation is all reals. You know it's all reals because x is being cube rooted. So whenever x is being cube rooted, the answer can either be positive or negative, which makes the domain all reals. To solve this problem, we can use substitution, and we can make x to the 1/3, which is the smallest number, y. So we just plug it in. So it's y to the squared, because x to the 1/3 plus 2 is 2/3 minus 7y plus 12 equals 0. And this is just a simple quadratic equation that you can just solve by factoring out. And that's going to be y minus 4 and y minus 3. So y equals 4 and y equals 3. But that is not the answer for this problem, because you have to go back to this equation and plug them in. So you have x to the 1/3 equals 4, and x to the 1/3 equals 3. So what you have to do is power it to the 3rd to get rid of this 1/3, but you also have to do it to the other side. So what you're left with is x equals 64. And you do that the same for over here. Power it to the 3rd to cancel out the 1/3, power 3 to the 3rd, and that means x equals 27. But after you find the solution, you have to go back to the domain restriction and see if it fits. And since the domain for this equation is all reals, these are the 2 answers.
Example 2. Okay, so for example 2, we're going to start out with this equation. X to the power of 4 divided by 2 plus 1 equals 9. First thing we're going to do is make sure that we get rid of this. We're going to subtract 1 on each side. That leaves us with x to the 4th over 2 equals 8. After that, we got to get rid of this right here. So what do? We multiply by 2 each side. That leaves us with x to the 4th equals 16. Now we have to get rid of this. So we're basically going to 4th root each side. Okay? So that leaves us with x equals 2. However, you need to remember, because we're because we're even rooting both sides right here, we have to add a plus or minus. So our actual answer is x equals plus or minus 2. That's right.
Example 3. Okay, for this equation, what you're going to be doing is factoring out and also substituting. So what you can do is factor out the least common variable between these 3 numbers, which is x, and the least common exponent, between these, which is to the 1/4. Okay, before you go with factoring, let's just create something to substitute it with to make it much easier. And we can make x to the 1/4, we can make that y. Okay, so we're just going to change everything in here, in these parentheses, to y, in terms of y. So this is going to be y squared minus 5y plus 6 equals 0. And this is just a simple quadratic, so you can factor it out by using trial and error. So that's y minus 3 and y minus 2. So, you know your solutions is, this is a lie. You know your solution is y equals 0, y equals 3, and y equals 2. But these are not the answers, because you have to go back and plug x to the 1/4 into these answers. So it's going to be x to the 1/4 equals 0, which is just 0, which is one answer. You have to go back for here too. X to the 1/4 equals 3. Cube root it, cube fourth power 3. X equals 81. You do that again for here. X to the 1/4 equals 2. Power it to the 4th, power it to the 4th. These cancel out. X equals 16. These are your three solutions, but just to make sure that none of them are extraneous, go back to the original equation and check the domain restriction. And the natural domain restriction is x is greater than 0. It's greater than 0 because in the denominator you can see that x is being rooted by an even root, which means the answers can only be positive. So that means x has to be greater than 0. And all of these answers, x is greater or equal to 0. So all these answers work.
So for example 4, we're going to start out with this equation. And it's basically the square root of x plus 5 equals the square root of x plus 1. First thing we need to do is isolate the radical with the most complicated radical, which we've already done. It's already been given to us. And we do this so that whenever we square both sides of the equation, to get rid of the radical, we free the most stuff. So we're going to start out by squaring both sides. On this side, it gives us x plus 5, because we got rid of the radical. And on this side, it's basically, you have to remember to FOIL. It's basically like this. So that gives us x plus 5 equals to x plus, 2 times square root of x plus 1. Okay. Now that we have that, we can just basically get rid of certain things to isolate this radical. So we're going to subtract x. Okay, and then subtract 1. That leaves us with 4 equals 2 times the square root of x. After that, we have to divide by 2. So still isolate the radical. And that gives us 2 equals square root of x. Okay, and then to get rid of the radical, we have to square it. So square both sides. And that gives us 4 equals x. However, we first need to check, since we even powered both sides here and here, we need to check and see if it fits into our original equation. So we're going to plug this number back in. So square root of 4 plus 5 equals the square root of 4 plus 1. And that equals, so 3 equals 2 plus 5 is 3. And so this works. And so our answer would just be x equals 4.
Check domain restrictions and try to isolate the most complicated radical.
Okay. You also need to remember you also need to remember that if you even power both sides, you must check your solutions to see if they are actually real solutions. Also, if you even root both sides, you must use the plus or minus. If you have odd roots or odd powers, don't worry about anything.
And number 5, always, always, always check for extraneous solutions. Okay, thank you for watching our video.
I hope you learned something today.